Welcome to UAV and to our laboratory. I am Engineer Melnik and I will be guiding you through all the stages of building our robotics projects. Today we are starting with one of the most important aspects of robotics, communication between two devices. This foundation will allow us to build our own custom control panel for future robot builds. For our projects we will use a Raspberry Pi Pico microcontroller, this one. And today we will be connecting it to an NRF24L01 radio module to establish wireless communication. Here on the table I have all the basic parts needed to build our radio device. A Raspberry Pi Pico, 7 colored wires, and an NRF24L01 radio module. For this demonstration I am using slightly longer wires to make everything more visible on camera, but keep in mind this can cause instability in the module's performance. Ideally, the wires should be as short as possible. I will update this in future videos. Here is a wiring diagram of our setup. For stable operation, I recommend using a separate power source for the NRF24 module that provides a reliable 3.3 volt. Once everything is prepared, we can solder the components together. We will need to make two identical devices, one to act as a transmitter and the other as a receiver. Now that the hardware is ready, let's move on to the coding part. For programming, I use MicroPython with a Tony IDE. It's simple to use and perfect for quickly developing and testing small devices like this. As a reference, I followed the instructions from this website. The link is in the video description. However, I ran into a major problem. The provided codes didn't work during startup. For a long time I thought the issue was with my NRF24 modules, but it turned out that the real problem was in the code itself. The issue is right here, around line 40. We had to rewrite this section and also made several other improvements for our test. Since we are only working with a Raspberry Pi Pico, we can define the configuration directly in the code. And for easier debugging, we will use the built-in LED on both devices. On the master, the LED turns on during transmission. On the slave, the LED lights up when it receives a 1 and turns off when it receives a 0. Finally, I added a simple button check to the master code. It reads the button state every time and sends the value to the slave. I connected the button to GPIO 0, but you can use any available pin. Now we can test both modules individually to make sure there are no errors on the COM ports. If both start up correctly, we can move on to testing them together. My test code will be also available in video description. Now we are going to test the full system with both devices connected. I am using a power supply to power everything, set to 3.3 volts with a limited current. When we turn it on, we can see that both devices together consume only about 0.36 watts, which is great for low power robotics applications. Let's see how the system behaves. At startup, the built-in LED on the slave is off. When I press the button connected to the master, the LED on the slave turns on. When I release the button, the LED turns off again. You might notice a slight delay. That is because there are sleep intervals in the code, but for our test that is perfectly fine. This confirms that the communication system is working, and that is exactly what we need to remotely control a robot. Today we successfully tested communication between two Raspberry Pi Picos using NRF24 radio modules. This is a key step that we will build on in upcoming videos, where we will create our own remote controllers for robots. If you enjoyed the video, don't forget to hit the like button. See you next time!